Imagine you had a tool that automatically scans your Solidity smart contracts every time you push them to GitHub, and finding vulnerability using AI and machine learning techniques, and eventually generates a report for you. Hey guys, it's Johnny time and I've got some exciting news for you today. Today we're gonna deep dive into a new video series that is going to be a game changer in the Web3 security space. Defender 2.0 by OpenZeppelin is here, and it's time to unleash its power. In each video, we will dive into a different module within the Defender 2.0 tool so you can get the most out of it. Today, starting with the code model. So whether if you are a blockchain developer, smart contract security engineer, or just getting started, this video series is tailor-made for you. You're gonna get so much value from it. So stay tuned, hit the subscribe button, and let's get started with the code module. Before we dive into the tool itself, I want to show you here the announcement from OpenZeppelin. So few weeks ago, OpenZeppelin announced the beta release of Defender 2.0, and here there is a huge thread on Twitter. I will put a link in the description below in this video so you can check it out yourself, all the details and the functionalities and the features of Defender. And here they also posted another thread specifically about the code model, which we're going to focus in this video. So both these tweets will be in the description below. Now, these are the Defender 2.0 docs, and these are the docs of the code model, which we'll deep dive in this video. And before we start, I just want to mention that currently Defender 2.0 is in a beta phase, and you cannot use it right now because there is a waiting list. You need to apply and join a waiting list, and OpenZeppelin is gradually giving access to new people to try out this tool. Now, I've got some good news for you, because if you're gonna use the link in the description below, my special link, and it could fasten and speed up the process of you getting access to OpenZeppelin Defender 2.0 before other people in this waitlist. So if you want to increase your chances of getting the access quickly, definitely join the waitlist using the link in the description below, and maybe you will get access to this amazing tool that's gonna blow your mind when you will see its capabilities in this video. And now it's time to see how Defender looks like. This is the Defender 2.0 dashboard. Very nice UX. And as you can see, we have here different modules, right? So we are now on the overview section, and we're going to focus today in the code module. But we have so many modules, and every module is an entire app, actually, entire tool by itself. And that's why we're going to have separate videos for every single one of them. And the cool thing about it is that the way they design it is like the whole life cycle of the DApp development process. So you should have security in mind during the whole phase, from the time that you code your DApp and start working on it and pushing pull requests to GitHub, to the audit phase when you're using an external party to give you a security review and check your smart contracts for vulnerabilities. Then in the deployment phase, you might fail, and there might be pitfalls where you can make mistakes. So they're going to help you with different features in the deployment phase. Monitoring, once you deploy the contracts to mainnet, to production, you want to monitor them, make sure there are no suspicious transactions and no one is trying to hack the contracts. Based on this monitoring, you can make actions and incident response. So if there is an attempt to hack the contracts, you can mitigate it and maybe stop the hack, and the funds won't be lost. Access control and logs and manage. But this is for the other videos, for the other video series. So make sure to follow and subscribe to the channel, where we're going to cover the other features as well. Now, today we're going to deep dive into the code model, which is an incredible, mind-blowing feature. And you can always go to the OpenZeppelin docs and deep dive into what is the code model, what are the use cases. It's automatically going to make a security analysis, static analysis to your smart contracts, find issues and help you fix them, and make a very nice reports. Now, this code model has two main processes. The first one is dependency checker. So every time you push your code to GitHub, you make a pull request, you have an engine that's gonna scan your smart contracts, and if you're using a library that has vulnerabilities, it's gonna spot it out and mark it as an issue. So you can be sure that you're not using some kind of vulnerable dependencies or library. This is one process. The contract inspector is another awesome process, huge one, that based on AI and machine learning, it finds vulnerabilities with static analysis in your smart contracts and give you a lot of insights, such as test suggestions. For example, it can tell you, hey, look, this function might be sensitive. You might want to add some testing or fast testing to this function to find more vulnerabilities. If you have unsafe external calls, it's going to point it out. You know, if you have standard security issues like low-hanging fruits, like re-entry attacks, like locked ETH in the contract, and it's even going to give you just this kind of low severity issues and informational issues like code readability and best practices. So it's going to give you a lot of value for free just by using this tool. And you can use it either if you're a developer or a smart contract security auditor, and you want to speed up your process and make sure that you're working with an AI by your side, helping you find all those kind of like known vulnerabilities and low hanging fruits, so you won't leave them in your smart contracts. Now, I won't go through all the documentation. I will leave a link in the description below so you can check it out and read it yourself. It's very nice to read. It's very organized, so I definitely recommend it. And what I'm going to do now is go right to the tool itself and show you how it works in real time, and it's going to be super cool. So this is the code module, and the first thing that you need to do is to integrate it with your GitHub account, because as I mentioned before, it's gonna connect to your repositories, and every pull request that you make, every time you push new code to your repository, it's gonna scan the entire smart contracts and find those vulnerabilities. So what I'm gonna do here is click install code app, and then it's going to redirect me to GitHub. I'm going to choose my GitHub account, and I'm going to authorize it to all my repositories, because I want all my repositories to be synced with the Defender tool. But you can also select specific repositories if you don't want to give access to all your repositories. So I'm just going to install it for the whole repositories, and I'm going to install the GitHub hub from OpenZeppelin Defender. Now, once you connected your GitHub account, this is the view that you're gonna see. So as you can see, I already played with the with the Defender code module already. So I have some reports already. And here in the settings tabs, you can configure your connection to GitHub. So you can uninstall it or suspend it and change the settings. And here you can see all the repositories that it's already synced from your GitHub account. And it's gonna scan the smart contracts every time you make a pull request for one of these repositories, right? I have created a new repository to try the tool and see what vulnerabilities and how it works, what vulnerabilities it's able to find and how it actually works. This is just a simple staking smart contract. Let's just open it locally with my VS Code. So simple staking contract, code dot, and this is our beautiful smart contract. As you can see, it's a new version of Solidity, kind of new. We use some ECDSA and ERC20 to interact with ERC20 tokens. And we have just a simple staking contract, 130 lines of code, not too much functionality. And now I want just to make a small change, create a pull request in my GitHub account and see how it triggers this new scan process. So just for the sake of the example, I'm just gonna update the README file, right? But before I do so, I need to create a new branch, because if I wanna make a pull request, I need to create a new branch and then create this pull request with the main branch. So I'm just gonna create a new branch, and let's call it, usually this is the way you work, by the way. When you work with a team, or sometimes even if you work solo, you create branches for every single feature that you are working on or smart contract that you are working on. Then you test it and then you merge it into main. So we will create this new branch. Let's say we're working on a new feature, and I will call it like new staking contract feature, right? So this will be our new branch where we are working on this kind of new feature. And now on my localhost, I want to change to this new branch. So I will do git checkout -b and paste the branch name. And now, as you can see, we changed for main to this new branch. Now, I just want to make a small update of the README. I will just add here a small exclamation mark. That's it. So we have a change, and git status. We can see that the README file was changed. Git add dot git commit -m. Let's call it a first feature commit, right? So this is going to be our first commit, and git push to push it to GitHub. And now we need to use this command to push it to our branch. So git push with this upstream. And let's put my password. And we push it, we push the code to this new branch, new staking contract feature. And now we're going to GitHub. I'm just going to go to my repository, and you will see that automatically GitHub spotted some changes. So it already spotted that this new branch has some new recent pushes that are advanced to the main branch. And I can click here, compare, and see the pull request. And I'm going to create a pull request with this new, just simple update of the README file. So I'm going to create a pull request, and upon clicking create pull request, at the same time, you automatically trigger the Defender code module. So now behind the scenes, if we go back to the Defender code app and we go to the reports and we will refresh this nice page over here, we will see that a new scan was triggered, right? Let's see how it looks like. Here we have the new scan. As you can see, it's the status running. It's currently running, so we don't have any issues. We have all the information about the pull request, the repository, first feature commit, right? We have the commit hash, the time, and we need to wait a while. It's going to take like 2 minutes because we don't have too much code. Obviously, if you have more Solidity contracts, it's going to take longer time. But in that case, we have only like 140 lines of code. So it should be not that much. And once it's done, we're going to see what the Defender was able to find, what kind of issues and vulnerabilities we have in the contract. Beautiful. The scan was completed. And this is how it looks like in the Defender tool. Here we have the commit name. We have some general information about the username, commit hash, branch, and etc. And this is the status and the results. So we can see that it took around 2 minutes to complete the scan, and the tool was able to detect 1 critical, 1 high, 1 low, and 8 informational issues. And here we have the details about the issues. Now, the cool thing is that if you also go to the pull request in GitHub, you will see here some kind of a summary of the report, and you're also going to get a report to your email. But if you want to deep dive into every single issue, you can do that here in the Defender tool itself. So the first criticality detected is locked Ether in contract, and in the contract staking.sol, it's impossible to withdraw Ether, and funds sent to it would be lost. For instance, consider removing the payable attribute or adding a withdrawal feature. Now let's see where it actually found this issue. So if we go to the staking contract over here, this staking contract, let's see how it works. We didn't really deep dive into how it works. So we have the stake function over here, and we specify an amount, and it's going to use the staking token transfer from function and transfer the token from the message sender to the smart contract. So we are actually staking a token, but this function, as you can see, is by mistake is payable. So users mistakenly might send ETH, native ETH to this smart contract through this stake function, and this ETH might be locked forever in the smart contract, and no one will be able to access it because there is no way to withdraw native ETH from the contract. And this is a very nice spot by the Defender tool, and now we can remove this payable keyword in order to make this function not payable. And hopefully, let's search if there are more payable functions here, because it doesn't seem that this staking contract is working with ETH. So there are no more payable functions. This was the only one. And this is, first of all, we got some value from the tool already, and we were able to fix one critical vulnerability that basically gonna help us not get ETH stuck in the smart contract, which is super cool. Now, the second vulnerability is, this is actually the dependency checker. As you can see, the first process was the contract inspector, and here we have the dependency checker that found that we have ECDSA signature malleability. we are inheriting from OpenZeppelin contracts 4.7.2, and in this version, the ECDSA smart contract is vulnerable to replay attack or signature malleability. And if we go here, we can see that we actually using this library in our smart contracts, and we use it for bytes 32, and we can scroll a bit and see where we use it actually. Here in the check function, we actually recover this from the signature, the owner of the smart contract. So we actually use ECDSA. And if we'll go to the package.json, we can see that we're actually using an old version of OpenZeppelin contracts, which is quite bad because this library has a vulnerability. So the next thing we want to do is simply just fix and update to the newest version of OpenZeppelin contracts so we can fix this vulnerability, and this high will disappear on the next scan. So I'm going to npm, and I can see that the most recent version is 4.9.3. So I'm just going to change here the version and make sure to remove both package.lock. And I also want to remove the modules, the actual OpenZeppelin modules, and install the fixed one without the vulnerability. So here is the OpenZeppelin smart contract. I'm just gonna remove it, gonna click here, delete, and move to trash. And now we can do something like npm I, again, npm install, in order to install the newest versions of the smart contracts from OpenZeppelin, and hopefully don't have vulnerabilities anymore with this ECDSA library. Cool. We fixed already one critical and one high. Now we have here some lows and informational, like missing docstring, constant not using uppercase, inconsistent order in the contract, functions are updating state without event emissions, and all these kind of things are issues that are for your information. It's not critical because there are not going to be money lost through them, but we just don't follow best practices, and it's better to fix them either for more better code readability or for gas optimization, such as using int and uint. Instead of int and uint, we should use int 256 and uint 256. This is a classic one, right? Because we want to be precise with what type we use. And you know what? Let's just try to fix this one as well, this int uint 256, and see if this kind of issue gonna disappear in the next commit and next pull request. So I'm gonna go back to the smart contract and just gonna replace every time we have uint, I want to replace it with uint 256, right? Now, if we went uint 16 or uint 32, it might be a bit bad, but as I can see, all the uints here are just uints. We don't have different size of integers. So I'm just gonna replace this uint to explicit uint 256, which is the best practice and the recommended way to do. And now we actually fixed already 3 issues. One is this locked ether in contract, the vulnerable library, and this int and uint. And now it's time to commit and push our code to this new branch and update this pull request and see if in the next report these issues still exist or we're able to clear them. So git status, git add dot git commit -m, fix some security issues, right? And then we're gonna git push. The pull request will automatically be updated because we still did not approve it. So this new commit will be added, as you can see, fix some security issues over here. And now it will automatically trigger a new scan. So we can go back to our reports and we should see this new scan because we just pushed new code to the pull request. There you go. Here, it's still running. We will give it like 2 minutes and let's see the results. Amazing, guys. As you can see, we reduced the number of issues from 11 to 8. It's still running for some reason, but let's go in and see what issues it found this time. Beautiful. We cleaned 1 critical, 1 high, and 1 node informational. As you can see, now that we fixed these vulnerabilities, these issues, the report doesn't show them. So this is the way to go. This is the way to create and develop DApps, you know, with security in mind all the time. Every update, every pull request that you make, you want to see all the vulnerabilities that you might introduce to your smart contracts and clear them and fix them one by one. And I love this approach and I love this tool by OpenZeppelin. OpenZeppelin. I also tried it actually with Damn Vulnerable DeFi. So you know that I have in my channel the playlist of how I solve Damn Vulnerable DeFi on this channel. So I used the new version, Damn Vulnerable DeFi version 3, and we can see that it was able to spot some security issues, some critical ones: re-entered code, locked Ether in contract, missing doc string, lack of gap variables for upgradable contracts because of the storage issues. You know, a lot of issues, use of TX origin, and it's super cool because you can use it with any repository, whatever smart contracts you are creating or auditing in your GitHub account. And it's very nice and easy to integrate and very nice to work with. Now, obviously, this God model is amazing, but we should not rely on automatic scanners like static analyzers, even if they are using AI or machine learning techniques. And OpenZeppelin also does not believe that this should be enough. That's why we have all the other modules, right? The code modules is only in the beginning while you create your smart contracts, while you develop them, and while you are working on your product. But once you're ready for production, then you go to the audit phase and you request an audit from security professionals, and then the deploy phase. So this is just the development phase, and this is a way basically to go hand in hand in your development lifecycle together with some amazing tool and AI based on AI and machine learning to help you find all these low-hanging fruits, all these security issues before you go to audit. So you can come more prepared to your audit, and you always write the code with security in your mindset, which is amazing, in my opinion, in a game changer in the industry itself. Now, as I mentioned, this is in a beta version and there is a waiting list, which means that you cannot right now use this tool. You have to join the waitlist first, but use my link in the description below in order to speed up the process, because the team will see that you sign up through joining time. You're either my student or my subscriber, and they will see it in your application, and they will speed up and move you up in the list so you can get early access to this amazing tool and you can play with it and try out yourself. It's completely free for now, so definitely check it out. Please, if you enjoyed this video, make sure to smash the like button and subscribe to the channel for the more video series and more awesome smart contract security content and tutorials. And if you have any questions, of course, feel free to ask them in the comments below. DM me on Twitter, on LinkedIn. I will be more than happy to help you. Any questions that you might have, just write them in the comments below. Thank you so much for learning with me and helping secure the Web3 security space, and I will see you in the next tutorial. Bye bye.